On part 1 of our look at S5 Solar Calculator, we discussed the importance of properly designing your solar array and showed you what information you'll need to enter to pull the correct load test data for your project. In part 2, we're going to generate our design and see what layout options the calculator has so you can get the most out of your system. Then you'll find out about all the information that's in the bill of materials available for download at the end. Let's get back to it.
So from here, the next step is going to be defining the size of our building.
Sure.
And as I'm doing this, I'm going to speak to why this is so important, but I really can't speak to it enough at this point because it's the easiest thing to miss. There are prompts that will make you do it, but you know, if you're new to this, this could be one of the more confusing things where you're not sure why you're entering this information. So the first thing we're going to do is deselect the roof. You'll see there's a yellow outline still around the roof, and we still have this roof 1 open on this right-hand tab, I guess, for lack of a better word. But what I'm going to do is I'm going to click off of the roof, and you'll see that now the roof is surrounded by this purple-blue outline. And what that line is indicating is the exterior outline of the entire building, not just the roof we're putting solar on. What we're going to want to do is we're going to start dragging this line to encompass the entire building.
Sure.
So the reason why this is important, and anyone who's watching this who's familiar with ASC 710 or any of the other versions already probably knows where I'm getting with this, but this is defining what the size of the building is for the sake of deciding what the least horizontal dimension is. This is a very important input when designing to ASC 7. It's the simple way to put it is what's the difference between 2 parallel lines that encompass the entire building. Mm-hmm. And you might ask, why would I want to know that? I'm not putting solar on my entire building. And it's going to change the size of your wind zones. You'll see that as I define the building as being larger than just that one roof, the wind zones being shown with these blue, orange, and then green areas is the wind zones on the roof. And you know, another good illustration of why it's so important to draw the full roof, not just where you want your array, because otherwise your wind zones aren't going to mean anything.
I mean, they say they changed pretty significantly there, so obviously if we hadn't have done that, it was not going to calculate these things properly at all, which leaves unsafe practices amounting, right?
Mm-hmm. And that doesn't mean you have to put solar across the entire roof.
We
can, of course, define down with the combination of setbacks, deleting modules, obstructions, areas that we don't want solar. So we can still have the array size and the array shape and the area that you want it.
Yeah.
You just wouldn't do it by drawing your roof not over the entire roof.
This just helps calculate the most accurate conditions that whole building is going to be under, and of course that includes the roof.
Exactly. Well, we have as we were talking there, you saw I dragged my purple line around the entire building, encompassing the entire building, and you'll see that when I did so, the wind zones got larger.
Yeah.
And you'll see that if you want to toggle your wind zones to view them or not, you can do so. You can also hide your building outline. And at this point, I'm actually going to do that. I'm going to hide my building outline. So at this point, we're ready to click on Generate Design, which is going to populate, based on the information we've entered at this point, what the calculator thinks is the best array.
Sure.
And then we can adjust from there. So let's illustrate that.
Take it away.
Perfect. So you'll see it populated the array in the area that we defined with our setbacks, with the roof size. You'll see in this case, the calculator wasn't too shy about putting modules at least partially into wind zone 3.
Yeah.
There could be cases where your wind forces are higher, or maybe the clamp to seam connection is a little bit weaker, and the calculator might say we can't put modules into wind zone 3 because there's not enough seams to be able to provide enough frequency of attachment.
Of course.
So in this case, we're not dealing with that, but just know if you do feel like there's modules that aren't being populated in the corners, or maybe even along the edges, that's almost certainly why.
All right.
But we're not dealing with that here. The other thing that I am going to point out right away that most of you have probably already seen is the calculator defaulted to column gaps in between pairs of columns. This is very common to see in the field, and actually in a lot of cases is desirable. You know, you might not get that 100% or 99% roof coverage that sometimes is desirable, but having walkways every so often allows easy access to any module. If you need to go up there and maybe provide maintenance on a module, adjust wiring, maybe a module even needs to be removed, This makes that much easier. And maybe you just want to go up and admire your beautiful solar array.
Why not?
Yeah.
I know a lot of places that I've worked with and been on for installs. I mean, it really helps with O&M work. Who wants to have to trample over a bunch of stuff or precariously hang above it? I don't know, with a crane or something like that.
Yeah.
Let's be honest, sometimes it's really helpful. And if you've got room to breathe on that, great. But obviously, some people would like to use the most of their roof, and we've got something for them then too, right?
Yup, absolutely. So maybe this isn't for you. Maybe your decision is to have as many solar modules on the roof as you possibly can. So we're going to come over here to the System tab, and we didn't address this before because I was saving it for now, but you have a layout option preference. So you can leave it as no preference. The calculator will default to what it thinks is best. In this case, clearly it defaulted to pairs of modules with a gap.
Yeah.
There could be a scenario where it defaults to full coverage.
Okay.
But the nice thing is that you can switch it from one to the other, and I'm going to illustrate that here. So if I wanted to go full coverage, it's as simple as selecting it there, acknowledging that it will change your array, obviously. And then once again, I'm going to zoom out so we can get a full coverage or full visual. And then I'm going to click on Generate Design again. And you'll see now that the array looks quite similar, but we have more modules on the roof, which is, maybe for your situation desirable. I don't think this particular project needs it. And actually, before I talk about this, I'm going to switch it back to pairs of modules equal gaps, or in this case, AdTouch is called pairs of modules. Acknowledge that again and Generate Design again. And I'm going to start talking about this, but you might, say we weren't happy with our design. Say we wanted to change something. What are my options? Well, you have lots of options. I'm going to answer my own question here. If we wanted to delete a module out, it's super simple. You can just select a module, select multiple modules, and click on this little trash can button. Say you wanted modules to actually be closer to the rake or maybe further away from one of the rakes. You can define your setback further and push everything away. It might change your design, but this is where you can kind of play with it, see what you like, see what you don't like, and tweak your inputs that gives you a better result. Maybe one of the lines you drew wasn't perpendicular to one of your other lines.
Sure.
And there's maybe a row, this is quite common, you might see a row or a column that seems to be cut off. Let me zoom in here. For example, maybe this line I drew for the rake was, not a 90-degree angle to the ridge, and this column was cut off halfway down because the setback interfered.
Sure.
You have full design ability at this point still. You can click back onto your roof, you can move your nodes around. In this case, I'm just going to put it back. But you can adjust, right? You can say, maybe your line wasn't drawn perfectly and you can make it better. Or maybe an entire section of modules really shouldn't be there just because you know that you can't fit that many modules. So you can delete those modules out. There's plenty of things you can do. This will give you a really good idea, and there is plenty of room for tweaking the design and making it
perfect for your roof.
Exactly.
Right? All right.
Exactly. Doing it the right way. So I'm going to deselect the roof again. There's other things you could do here as well. You could add in obstructions, maybe an obstruction on the roof. Maybe it's a roof vent that you don't want to put a module there. Maybe you want to even say, I want a 12-inch setback from this roof vent. There's capabilities of doing that. If you wanted to say, I have a tree here and I'm nervous about shadowing, you can draw that as well, and it'll illustrate the shadowing, so it'll remove modules from a portion of the roof, and you don't have to do any guesswork. So I don't think we want to dive into the weeds on that one right now, but just know it is there. Reach out to us if you have any questions. Maybe we'll come out with a sequel video. I'll see you here again soon doing that. But for now, let's go a little bit further. So best practice, let's save our array now that we're good, we're happy with it. We'll click on the Reports button here.
All right.
There's a couple different things you can download. The one I want to focus on, the most important one, is going to be this Bill of Materials download PDF one.
And this is what everyone's looking for, obviously, too. It's kind of what it's all about, is getting to this point so we can have everything spelled out and really get the direction that we need here on paper.
Absolutely. This is your output. This is what you can review with your customer, review with your contractor, even submit for consideration during the approval process.
Sure.
And I'll point out which parts of this might apply to each of those scenarios.
Okay.
So up here on the top, you have your address, your contact information, good things you might want to have on something that you're submitting for approval or as part of a package. These next few are mostly going to be summary of the inputs.
Sure.
People want to know what inputs did you put in the calculator. is it accurate to the project? So we want to make that as clear and concise as possible. So you'll see the module itself, the quantity of the modules, the system size, what S5 clamp is being used.
Yeah.
Further down here, this is more S5 specific, engineering specific, actually. Your factors of safety, and then also the allowable clamp forces in different orientations. For solar, your most important one is going to be your allowable clamp force in the upwards direction.
Sure.
We need to know how much wind force each of our clamps is going to be able to handle. And worth repeating again, if this is being reviewed by an engineer, we have third-party lab reports that we can provide you. Even if you don't know that you're going to need it, it might come up at one point. You never know if a jurisdiction is going to require something that's unexpected. And it's just nice to know that you have some options.
Better to have it and not need it.
Yes. Design criteria, this is really just a summary of the inputs you put on the site tab.
More recap.
And here, we only have the one roof on the project, roof 1. If we had more roofs on the project, there'd be similar sections like this following. On this one, we just got the one roof, though.
Sure.
So it's a summary of the inputs we used on the roof itself.
Sure.
You know, you got your column spacing. You know, you might have been asking yourself, what's the distance between the columns, since I do want those gaps? In this case, you can clearly say that that's 14 inches.
All right.
This is decided on by the calculator based on the size of your module, your seam spacing, what kind of frequency of attachment you need, and making sure that we're getting a spacing that's going to work well for your system across the roof.
Absolutely.
Some other useful information here as well. I'm not going to read off everything, but one of the most important things that you should definitely be aware of that you will receive once you complete the calculator is your pressures. In this case, you know, the wind forces are the most serious one, the one we're designing around. Yeah. So we got uplift pressures for wind zone 1, wind zone 2, and wind zone 3. We also have downforce, and then also along the seam pressure and the lateral pressure, which applies more to seismic. Unless you're in snow country, you're probably not going to be too worried about that stuff, but it's good to have, and who knows, you know, you might have a very steep roof or a situation where you are designing around that parallel load testing.
There's a lot of areas that we obviously serve. We're an international company, so many of these places you may not have to worry about it. In other areas, it's going to be absolutely crucial. So we're covering your bases.
100%. This next section here is the bill of materials. So this is the bill of material for the entire project.
Yeah.
I'm going to illustrate this in a second, but if you have either multiple roofs on the project, or even if your roofs are split into multiple subarrays, which is the case on this one, you will get a further breakdown of the bill of materials for that particular subarray. Right. But this is the bill of materials you potentially could submit to one of our distributors.
Absolutely.
And get a full project wrecking quote. So on page 2, let me zoom out a tiny bit so you can see the whole thing. You'll see an illustration of how the solar is going to work on the roof.
Yeah.
This is great to have when you're presenting this to a customer, when you're showing, maybe the installers, so they have a good visual of what the end goal is. And it just, obviously, you want a picture. I mean, I don't think I need to explain that one any further.
And hey, you can hang it as a poster above your bed. It's time to replace that Justin Bieber poster anyways, right?
Yeah, speaking of Canadians. And it is worth noting, it's not ready yet, but we are in the process of getting something like this as a CAD drawing. We do make the call-outs for setbacks, for distances between columns and all that stuff, and that is shown earlier on. But we understand that a lot of these arrays, it will be nice to pull it into a CAD program and get any particular dimension you might need.
Sure.
So
yeah.
Not quite ready yet, hopefully soon.
Great.
So down here on page 3, we're going to see a breakdown of each subarray.
Yeah.
Well, the other subarray is going to be on the next page, but you understand what I'm saying. And you'll see that it's color coordinated. So this is the west side of the roof subarray, clearly. The dormer, if you can envision it, would be right here. And you'll see that almost all the modules in Wind Zone 2 or Wind Zone 1 require 2 PV kits per side of each module. But what this report actually does a really good job of illustrating is that certain modules, the ones that fell either partially or completely into Wind Zone 3, require another PV kit. They require a third PV kit on each side of the module.
Sure, yeah.
And this is accounted for in the bill of materials. The calculator's already checked to make sure that these modules fall over at least 3 seams. And it's very easy to see which exact modules need that extra PV kit, require that extra frequency of attachment. So that way, when you're on the job site, you're with your general contractor, maybe it's the general contractor showing this to his team, they know exactly which modules require that extra PV kit. There's no guesswork involved, and you can plan for it right from the beginning.
Yeah, and like you said, at least it calculates too that not only are you going to need that, but you have the seams to connect to right there. So it's not going to lead you astray. It's going to tell you exactly where it needs to go.
Exactly.
All right.
Yeah. So let's keep scrolling down here. Here you'll see a summary of this subarray. So you'll see the bill of materials for this subarray, not the other one.
Yeah.
And then the area, the weight, and the pressures that the subarrays create on the roof. You might not need it, but you might, so we want it there. That's the roof height there. This is the clamp you'll need, which is across the entire project. And also the solar module itself.
Great.
So let me zoom back out a little bit, and we'll look at page 4, which is going to look eerily similar.
Then what do you know?
But you'll see exactly which modules fall more into WinZones 3 than, or at least fall enough into WinZones 3 that they require a third PV kit.
Yeah, similar to the west side.
Yep, very similar. You'll see it on this one. There's actually, this module actually falls more into the Dormer WinZone 3, or the Dormer related WinZone 3. I'm not sure the best way to phrase that actually, but I think you guys understand what I'm saying. And it also requires a third PV kit.
And you know, some places that I've been on too, through talking with some installers, they would think in this case, why not just do 3 connection points all the way across? But what we're trying to do, it seems like with this, is just help assure people that that's not necessary. And that's also going to cost you more than is required out of this system. Why end up throwing more at this than is going to be necessary? We're all about just keeping the things economical and stuff. And this really helps you know for certain you're safe doing so.
Yep, you're exactly right. So the nice thing about using the tool that pulls in both the standard engineering and also S5's testing, it combines everything. So you know exactly, just like you said, you know exactly which modules need that. There's no guesswork. You're not taking the lazy way out of 3 PV kits per side of every module, or even 3 PV kits on the top and bottom row and the outside columns. Yep. Would it cost that much more? Like, I mean, I guess it depends on how you define that much.
Yeah.
But we don't want you to pay anything more than what you'd need. We want to give you an exact bill of materials and for you to go in confident in your design. Very similar to the last page here. It gives you a summary of this subarray. Yep. I don't think we need to talk about that again.
Yeah, this kind of breaks things down just a little bit more.
Yep. One thing I did want to touch on again, Patrick, was just emphasizing this was quite a simple project. We didn't deal with any obstructions.
Sure.
We didn't add a second roof, but those things are all quite simple to do. And once you understand how they're done, I think you'll see that it's quite easy to add in. So whether it's watching a follow-up video or reaching out to S5 or even setting up a Zoom call with one of us who can walk you through your specific project,
absolutely,
we're more than happy to do so. And we want to stand behind everything we're saying here, and we certainly plan on doing it.
That's going to do it for our look at the S5 Solar Calculator, which you can use for yourself over at s-5.com. Why go through the hassle of pulling together all this information yourself from various sources when you can easily get it all in one place? And like Jesse said, if you have questions about anything while designing your project, just reach out to us and we'll lend you a hand. Thanks so much for joining us on the Metal Roofing Academy. If you found today's information helpful, please drop us a like and hit subscribe. Your support means a lot to us. Take care, everyone.